Welcome to the Explainer. So today we've got a really exciting goal. We're taking this massive 30-module curriculum and distilling it down into your ultimate architectural blueprint. As we go through this full video, generate your own mental blueprint for building a full end-to-end automation framework from absolute scratch. We're talking about how Principal SDT actually constructs an enterprise-grade testing factory step by step. Let's get right into it. Okay, let's dive into this. Before we start building our factory, we really need to establish why we're building it in the first place, right? Manual testing, look, it's essential, but it's inherently slow and just so repetitive. You're basically trading hours for manual effort, staring at the exact same login screen for the 100th time. And that just leads to a lower ROI over time. But on the flip side, automation testing, it absolutely changes the game. It's faster, it's infinitely scalable, and it integrates right into your CI/CD pipelines. Honestly, generating an automated framework gives you massive ROI because, well, once the factory is built, the robots do the heavy lifting for you. So, here's our blueprint for this explainer. We're going to logically construct this massive system step by step. We'll start with the automation foundation, move on to core tools and architecture, build out the enterprise hybrid framework, look at CI/CD and scaling automation, and finally wrap up with the SDET career roadmap.
All right, Section 1, the automation foundation. Let's gather our raw materials.
You know, you really can't build a skyscraper on a swamp, and you definitely can't generate a full enterprise automation framework without mastering your raw materials first. So to start, we need the brain of our framework. That's your core Java OOP concepts, things like inheritance, polymorphism, encapsulation, and collections. This is the underlying logic. Then we need the eyes and the hands. That's your Selenium locators, XPath, CSS selectors, IDs. This is what allows your code to find and actually interact with specific web elements. You absolutely need both of these working in perfect harmony before you even think about writing a single script.
3. The source curriculum actually dedicates over 3 full hours just to mastering those Java basics. And why is that? Because a solid foundation is completely non-negotiable for an SDET. I know, it's super tempting to jump straight into making browsers click buttons, but without deeply understanding variables, OOP concepts, and exception handling, your framework is basically going to collapse under its own weight eventually. Moving right along to Section 2, core tools and architecture. Time to shift from basic scripts to advanced enterprise design. So, with the foundation poured, this brings us to a huge breakthrough in our design, the Page Object Model, or POM. Now, imagine you've written 1,000 tests and suddenly the login button on your website changes its ID. Without POM, you're manually updating 1,000 scripts. Literally an absolute nightmare. But POM solves this perfectly by cleanly separating your test scripts from the actual page architecture. So when the UI changes, you update your web element in exactly one place, and boom, all your scripts instantly inherit the fix. It's an absolute game changer for maintainability. And when you put this into practice, a real-world, enterprise-level folder structure brings absolute order to the chaos. You've got dedicated folders cleanly separated for your pages, your actual tests, utilities, configs, and test data. When you're managing thousands of automated tests, knowing exactly where your configurations live versus your test data, honestly, that's the whole shebang. That's what separates a beginner from a principal automation architect. All right, Section 3, the Enterprise Hybrid Framework. We're expanding the engine now. So this is where we turn our testing engine into a true hybrid framework. It's a powerhouse because it pulls together the absolute best methodologies out there. We're combining data-driven testing, using things like Apache POE to effortlessly read massive Excel spreadsheets, with keyword-driven testing for all those dynamic actions. Think about it. Instead of writing 50 separate tests for 50 different logins, you write one test and just feed it a spreadsheet. You're handling massive data sets seamlessly without duplicating a single line of code. To make things even more robust, we bring in behavior-driven development, or BDD, using Cucumber, and this flow is just beautiful. It starts with your feature files, written in plain English using Gherkin. Those outline your scenarios, which map cleanly right over to your step definitions in Java, and then everything is executed by the runner files. It completely bridges the gap between business requirements and executable code. I mean, product managers can literally read your feature files and know exactly what the automation is doing. Now, what's really interesting about this slide is that modern automation isn't just about the UI. The UI is just the paint job, right? We have to test the engine under the hood. Enter Rest Assured API testing. Our factory needs to be able to fire off HTTP methods, get, post, put, delete, straight to the server. Validating JSON schemas and handling authentication tokens, This ensures that the back-end data actually powering your web app is totally bulletproof.
Which brings us to Section 4, CI/CD and Scaling Automation. Time to put this thing on autopilot. Okay, so we've built this incredible machine, but we still have to manually press the start button ourselves. Let's fix that and actually automate the factory. By integrating our framework with GitHub and Jenkins, we create continuous integration and deployment pipelines. Think of Jenkins as the automated conveyor belt of our factory. The second a developer commits new code to GitHub, Jenkins wakes up, triggers a build, and runs the entire scheduled suite automatically. No human intervention needed. You're literally generating feedback for your dev team while you sleep.
But here's the catch. As your test suite grows, running tests sequentially, one by one, creates this agonizingly slow feedback loop. The fix? Parallel execution. By bringing in Docker containers and Selenium Grid, we set up a central hub that pushes tests out across multiple nodes at the exact same time. So instead of waiting hours for tests to run sequentially, they're distributed across isolated containers for lightning-fast feedback. It's a massive speed advantage. When you zoom out and put it all together, you see this awesome end-to-end release conveyor belt emerge. You start at requirement analysis, flow right into script development, hit Jenkins for that CI/CD execution, handle your release validation, and cap it all off with production smoke testing. A fully generated automation framework isn't just a folder of scripts. It's a living lifecycle that seamlessly drives a real-world software release from the planning stage all the way to production.
Finally, Section 5, the SDET Career Roadmap. Let's talk about you.
Let's move to and see how this builds your career step by step. Because mastering this enterprise-grade architecture seriously elevates your professional trajectory. You might start out as an automation tester, focusing on those basic scripts. But as you learn to build hybrid frameworks and CI/CD pipelines, you level up to an SDT. From there, your ability to scale these systems makes you a lead SDT, then an automation architect designing the blueprint itself, and eventually a QA director overseeing the whole strategy. Mastering architecture is literally the engine of this progression.
And the curriculum makes a really strong point here. Knowing the tools just isn't enough. You have to be able to confidently articulate your design choices. So interview prep at this level means tackling scenario-based problem solving and really defending your framework. When you're sitting across from a hiring manager, you aren't just rattling off answers to Selenium questions. You're explaining why you went with a hybrid POM design for scalability, or how you wired up Jenkins for scheduled execution. You're speaking like an architect. And that leads us to a really crucial question to leave you with. You've generated a massive, scalable enterprise automation framework today. But look, technology never sleeps. As AI tools increasingly reshape QA, generating their own test scripts, analyzing failures on the fly, what new skills are you going to need to maintain and evolve this enterprise architecture in 2026 and beyond? Keep learning, keep building, and keep expanding that factory. Thanks so much for hanging out with me on The Explainer, and I'll catch you on the next one.